Welcome back to The Explainer. Today, we're diving into how to build genuinely smart dynamic AI agents using a really cool framework called LangGraph. We're going to go way beyond simple chatbots and start building agents that can actually reason, loop, and tackle some seriously complex problems. Think about it. Most simple AIs are kind of like a train on a track. They just follow one single path. If anything unexpected comes up, the whole system just derails. But real-world problems aren't a straight line, right? They need flexibility. They need the ability to go back, rethink things, and choose a totally new direction. And that is the huge shift LangGraph makes possible. We're moving away from these rigid, one-step-after-another chains and into the world of stateful graphs. This lets us build dynamic, cyclical flows, and what you get are agents that are way more resilient, way more adaptable, agents that can plan, self-correct, and handle really sophisticated tasks. Okay, so let's get into it. We're going to build out our agent piece by piece, starting with what is absolutely the most critical component, its memory. In LangGraph, this is officially called the state. The best way to think about the state is like a big project whiteboard in an office. It holds all the current need-to-know info, the latest messages, data you just got from a tool, whatever the user asked for. Anyone on the team can just look at it and know exactly what's going on. It's the single source of truth for the whole operation. Now, to keep this whiteboard organized, you can't just throw information at it randomly. LangGraph makes you define the structure of the state right at the very beginning. And this is a super important first step because it forces you to think clearly about what information your agent needs to keep track of, which gives you a really stable foundation to build on. And you've got two main choices for how you define that structure. Typedict is simple, it's great for quick prototypes, but for any serious production-level agent, Pydantic is absolutely the way to go. Why? Well, its strict data validation is basically your quality control. It catches errors and stops bad data, maybe from a confused LLM, from messing up your agent's memory and causing the whole thing to fail. So here's a classic problem you run into with complex systems. Imagine two different parts of your agent. Maybe one is analyzing text, the other is calling some external tool, and they both finish their jobs at the exact same time and race to update that whiteboard. What happens then? Well, you get a data collision. Without a clear rule, one of those updates could just completely overwrite the other one. You lose information, and now your agent is totally confused. But luckily, LangGraph has this built-in and really elegant solution for this exact problem. And that solution is something called a reducer. It's basically a special function that acts like a traffic cop for your state. It gives a clear, predictable rule for how to combine new information with what's already there. It makes sure that your agent's memory stays perfectly consistent no matter what. And here's a perfect example that makes it all click. When you're dealing with a list of messages in a conversation, right? You never want a new message to replace the entire chat history. So by using operator.add as the reducer, you're just giving the state one simple instruction. Always add new messages to the end of the list, never overwrite. It's a simple rule, but it guarantees the integrity of your whole conversation. All right, let's move on to the next piece of the blueprint. We've got our central memory, the state. Now, our agent needs some skills, and we give it skills using something called nodes. So nodes are like the specialized employees in our automated office. Each node is just a function, and it does one specific thing. It reads the project whiteboard, our state, to get the context it needs, it does its job, and then it reports back with only the new information it came up with. Now, what's really interesting here is that there are some very strict rules for how these nodes have to behave. A node only takes the state as its input, and it only returns a dictionary with the changes it wants to make. It never, ever touches the state directly. Now, that might sound a little restrictive, but it's actually what makes the whole system so predictable, so testable, and so much easier to debug when things go sideways. All right, so we've got our memory, the state, we've got our skilled workers, the nodes. Now we just need to tell them what to do and in what order. We need the office workflow manual. And in LangGraph, those are the edges. Edges are pretty much what they sound like. They're the lines that connect the dots. They define the pathways for your agent's logic. An edge can be a simple arrow that says, after you do A, always do B. Or, and this is where the real power is, it can be a dynamic conditional path that actually looks at the state and intelligently decides where the workflow should go next. Okay, so let's put these three things together, state, nodes, and edges, and just quickly walk through how you'd build a simple agent. Let's say one that processes regulatory notices from emails. You can see how we build this out step by step. First, you define the state, that's our memory. Then you add your two worker nodes, one to parse the email, another to make a decision based on it. And finally, you just draw the edges that connect them all into a complete logical workflow, from a clear start to a clear end. It's a really clean and modular way to build. So if you take one thing away from this, it's this powerful separation of concerns. You have the state for memory, nodes for action, and edges for direction. This blueprint is what makes LangGraph so powerful. It means you can easily swap out your agent's brain, like, say, a specific LLM node, without having to rewrite all your other logic. It makes your whole system so much more adaptable. By mastering these three core components, state, nodes, and edges, you really do have the fundamental blueprint to build some truly powerful AI systems. You could build an AI research assistant that browses the web on its own and compiles reports, or a customer service agent that can pull from multiple databases to solve a problem. The possibilities are just huge, and it all starts with this blueprint.